Good morning, students. So today we are discussing some of the formulas we already discussed in the thermodynamics. So first formula is energy change. Energy changes. So change in internal energy will be equal to QV. Okay, that is heat change at constant volume, and delta H, change in enthalpy, is equal to QP, that is heat change at constant pressure. Now, second case, enthalpy. Enthalpy is denoted by H. H is equal to U plus PV. Okay, so delta H, change in enthalpy, will be equal to delta U plus P delta V, or we can write delta H is equal to delta U plus delta NGIT. Okay, next, third case. Next, heat capacity. Third formula is heat capacity. It is denoted by capital C, which will be equal to Q by delta T. Heat change by changing temperature. Okay, now next one is first law of thermodynamics. First law of thermodynamics. That is, change in internal energy will be equal to Q plus W. This is the first law. Next, so enthalpy of reaction. Enthalpy of reaction, delta H, will be equal to sum of the enthalpy of formation of products at standard state minus sum of the enthalpy of formation of reactants at standard state. Okay. Also, at standard state, heat of formation of every element will be taken as 0. Okay. Now, next one, Cp minus Cv equal to R. That is heat capacity at constant pressure. Cp represents heat capacity at constant pressure and Cv represents heat capacity at constant volume. Their difference will be equal to a constant R. Okay. Also, delta H sublimation at standard state will be equal to delta H fusion plus delta H vaporization. Okay, this is another formula. Now, next one, enthalpy of reaction can be calculated. Standard enthalpy of reaction can be calculated if the both enthalpies of products and reactants are known. Okay, so standard enthalpy of reaction standard state will be equal to sum of bond enthalpies of reactants minus sum of bond enthalpies of product. Okay. Of products. Next, ninth formula, Hess's law. According to Hess's law, delta H equal delta H1 plus delta H2. So, different steps, the same reaction is taking place. Its sum will be the enthalpy, change in enthalpy. Okay. Next, entropy. Change in entropy, delta S, will be equal to Q reversible by T. Q is heat change at in the reversible process. Q reversible means Q, heat change in reversible process, divided by temperature. Also, delta S equal delta H, change in enthalpy, by T. Now, next formula, delta G. Delta G is equal to delta H minus T delta S. This equation is known as Gibbs-Helmholtz equation. Next formula, in the case of spontaneity, for spontaneity, we know delta G will be less than 0. So delta G will be a negative value for spontaneous process. We already discussed this. Next, G is equal to minus W. That is work done, useful work. G is equal to useful work. Delta G is equal to change in Gibbs energy will be equal to useful work. Next case, delta G, standard condition. Delta G will be equal to delta G standard. Standard delta G, change in internal energy for standard state plus 2.303 RT log K. This will be the equation. So delta G can be calculated from delta G standard plus 2.303 RT log K. This equation is known as Van Hoff reaction isotherm. Okay, Van Hoff reaction isotherm. Now let us do one problem in thermodynamics. First one, for a reaction 2A plus B gives C at 298 Kelvin temperature and delta H is given 400 kilojoule mole inverse and delta S is 0.2 kilojoule Kelvin inverse mole inverse. This is the unit for delta S. At what temperature will the reaction become spontaneous, considering delta H and delta S to be constant over the temperature range? Okay, now we know delta G will be equal to 0 if the reaction is equilibrium. Okay, also we know delta G will be negative if the reaction is spontaneous. So we have to find the temperature when delta G is negative. And also we know the formula delta G is equal to delta H minus T delta S. This will be equal to 0 at equilibrium. Okay, so at equilibrium delta H minus T delta S is equal to 0. And we know delta H is given, delta S is given. So delta H is equal to T delta S. Okay, so we can find T from this. T is equal to delta H by delta S. Okay, at equilibrium the temperature will be delta H is given 400 by 0.2, that is equal to 2000 Kelvin. At equilibrium the temperature is 2000. Okay, and we know delta H minus T delta S must be negative for spontaneous. That means T delta S must be greater than delta H. Okay, at this state the reaction is spontaneous. This means that at equilibrium 2000 Kelvin, the temperature greater than 2000 Kelvin, only the reaction is spontaneous. So for the reaction is spontaneous, the temperature must be greater than or must be above 2000 Kelvin. This is the temperature. So temperature above 2000 Kelvin, the reaction will be spontaneous. Okay. Next problem. Equilibrium constant for a reaction is 10. What will be the value of delta G standard at 300 Kelvin? We know delta G will be equal to 0 at equilibrium. So delta G standard will be equal to minus 2.303 RT log K. Okay. So K we have to find. Delta G will be equal to equilibrium constant K is given. K is equal to 10. Okay. T is given 300 Kelvin. So this will be equal to 2.303 into 8.314 R into 300 into log 10. Okay. It's equal to minus 2.303 into 8.314 into 300 into 1. Okay. So at last the value will be minus 57.4444 kilojoule. This will be the delta G standard. Okay. Next problem. Calculate entropy change in the surroundings when 1 mole of H2O liquid, that is water, is formed under standard conditions. Delta H of formation standard is given. Minus 286 kilojoule mole inverse. So, the equation will be H2 plus half O2. Okay. Gives liquid H2O liquid. Okay. H2O liquid. Delta H heat of formation standard is given minus 286 kilojoule mole inverse. So, during this formation, the system, this much energy is evolved to the surroundings. Okay, this much energy. So, when 1 mole of H2O is obtained, this much 286 kilojoule heat is evolved. That means surroundings will absorb this much heat. So, we can write Q of surroundings will be equal to plus 286 kilojoule mole inverse. This much heat is absorbed by the surroundings. From this equation is given, this much heat is evolved to the surroundings. So, surroundings will absorb this much amount of heat. So, Q surroundings will be equal to plus 286 kilojoule mole inverse. So, what we have to find? Calculate entropy change in the surroundings. So, delta S of surroundings we have to find, which will be equal to Q surroundings by temperature. Temperature, standard enthalpy of formation of water we know. Standard enthalpy of formation of water is 298 Kelvin. It's a constant value, standard enthalpy of formation of water. So, Q surroundings is 286. This will be the value is 0.9597 delta S kilojoule Kelvin inverse mole inverse. This will be the unit. So, 0.9597 kilojoule Kelvin inverse mole inverse. Okay.